In part A of this problem, there's a sound source at a frequency f sub s, s for source, of 1 kilohertz, moving toward a listener at a speed of half the speed of sound, where v is the speed of sound. We're asked to find the frequency heard by the listener, represented by this ear I'll draw here. We'll do this using the Doppler shift equation. Frequency heard by the listener is v plus v sub l over v plus v sub s times the frequency of the source. In this equation, the positive direction is always from the listener to the source. And here, the source is moving in the opposite direction, so the velocity of the source is minus v over 2. The listener is stationary, so when we substitute these values, cancel all of the v's, we see the frequency heard by the listener is twice the source frequency. That gives us 2 kilohertz. In part B, the source is stationary, but the listener is moving toward the source at half the speed of sound. We're again asked to find the frequency heard by the listener, so we'll write the Doppler shift equation. And remember that the positive direction is always from the listener to the source. Now we see that the listener's velocity is positive v over 2. The source is stationary, so when we substitute these results, cancel all of the v's, and simplify, we see that the listener now hears a frequency of 3/2 the source frequency. That gives us 1.5 kilohertz.